Welcome, data enthusiasts. We are Zuma, the recruitment consultancy focused 100% on data tech professionals in and around the Berlin region. And this is our podcast, Data for Good, connecting you with all things data. And today, really pleased to be joined by Igor Slinko. And Igor is lead computer vision engineer at SportTotal TV. If you don't know, SportTotal TV is one of Germany's largest multi-sport streaming platforms. And as well as live sports, the platform allows sports clubs or businesses to upload their own content too. So a really quickly evolving product platform. Igor, firstly, was that accurate? And how's it going today?
All good, all accurate. Thank you for having me. All good. How about you?
Really good. Thank you. I'm excited for this one. Being a sports fan myself, I understand that today we're going to talk about computer vision for sports streaming and analytics.
What's the plan? Should we dive in?
Yeah. Let's dive into it. I've got a bunch of questions that I want to ask you, and then some that will come up, no doubt, from my questioning. So if we start high level, talk to me about what computer vision means for sports gaming and sports games and how it's used.
So basically, like computer vision itself is a huge field, like everything that connected to the images, and neural networks, and even not just neural networks, will be counted as computer vision. And for sports, I think use most of the normal tasks that people solve in computer vision. I think the basics are image classification, detection of the objects on the image, objects tracking, object segmentation, many other tasks. We can go into details. Even generation of the content. If you heard of Midjourney, DALL-E, Stable Diffusion, they are starting to be used in the sports topics. Basically, if you want to build a good system that uses video stream as an input and tries to have some insights about the game, you will need, I think, to implement several essential stuff like players detection and ball detection. If we are talking about football, it would be ball detection. Like in hockey, we actually talk about multiple sports, because in SportTotal we work on football, basketball, ice hockey, volleyball, and we plan to conquer all the team plays games in the world. So so the ball detection, the players detection. Also, between the players, you need to understand which team is the player. Is it a goalie? Maybe it's not a player, maybe it's a referee or linesman. So this is image classification. And also you need to track all these people around and track the puck or the ball. So you will need decent tracking on top. And then you will have this bells and whistles. For example, you can use pose estimation if you want to classify some specific moments of the players, like throw-ins, for example, right? So now it goes more complicated. So where do you want me to dive in?
We could go into any of those areas, but we've only got 30 minutes, and I do have a couple of questions alongside that. So let's talk about, perhaps, if we go into the different types of computer vision, what types are the most prominent and the most challenging for you in your role as a lead of computer vision engineering?
Yeah, the basic issue that we are trying to beat is the video quality, I think. So I mean, I will talk a little bit about our setup, the normal setup, so you will understand what kind of video we're getting in as an input. So we have this camera, it's a physical camera, it has like through lenses, and we put it on the field. You can actually rent it, like if you want, like just go on the site, like it's not commercial, but like you can rent it like for your field if you want. So it's like the device like that has three lenses, and it broadcasts like two things. It broadcasts the panoramic image of the field, like it stitches the cameras, and this is another thing that we are doing. Like it's also computer vision task, like how to stitch different views in one panorama. And also we broadcast, like the moving crop of this panorama, where the action of the game is going on. So yeah, so on this setup, the problem is that even though the cameras are 4K, it's really hard to put like really good hardware inside one box. So you can't like record 4K like panorama. It's like a very huge file. And this means that if you're like using analytics, like if you're like calculating any analytics, you need to work in this smaller image, like that is, I think, like HD image of the panorama. It's actually more than HD because like it's very long, but like on the length, on the height, it's just HD. So, and this makes a challenge because like on this image, the players are very small. So you need to have the good detection on very small players, like maybe like several pixels is one player if he is or she is on the background. And it makes everything more challenging. So you can't take like top of the shelf YOLO V5 without any training and like expect that it will detect perfectly the person on the background of the image. So we obviously train it on our own recordings, and the first challenge is to have a very good data set of all the games like going on in different places, in different weather conditions, in summer, in winter, everywhere. So, and in this view, we're like pretty in a good shape because like we have hundreds of cameras all over the Europe actually, and some in US. So we have like a pretty good like variable data set, right? With a good variety of inputs.
Aha, okay. So masses of data, but also variety. So you cover all areas. Okay.
Yeah, and this is actually something that is not very easy for the new company to get into this field, because like if you put a camera on a new field, you need to like collect some data, and like it won't work good at the first place, right? Like, but we have like hundreds of those, so mostly like everything that you might see on the field, like birds eating some crops on the field, could be covered in some old data sets we have.
Interesting. But if somebody were to rent this and they've not used them before, then the birds eating crops on the field might just, because the models aren't trained, would just look like a football or a pair of boots or something.
Yeah. We like at first, like when we saw like multiple false positives of the ball or foots of the players, like it was the birds, it was really interesting. So like having this pipeline of getting new data, like mixing it with the existing data set, calculating, like training the model, like making sure that the model didn't degrade using this new data, like it's a hard task. So basically this is a challenge, and what you train on top of this, it has like second order importance, because like you can train detection, you can train segmentation on top of it, you can train like you can try different tracking methods, but like collecting this data set, this is crucial actually.
Interesting. So does it help if you wanted to get more accurate models for the analysis of football streaming, would it help to also be gathering data from basketball games and hockey games, because it's more variety of data, it's more understanding as to how balls move, how the weight of balls move across a screen or across a pitch, line distancing, that kind of stuff?
Right now, we don't mix any data set. It's maybe an interesting idea to think about. Like, since we have this like continuous stream of information, like it's usually not a problem to enlarge the data set, right? So like if
Mm,
we have like some new point of view, like for example, we put new lenses on the camera and now the pitch is more like fisheye, right? So we just collect some streams and we like put it in the training loop and everything. Like after this, it become better. So every time we have like something really strange, we just put it in the training loop. I'm not sure that like putting the basketball games will help because like the same stuff is going on. Like if you have like football pitch, you expect that there would be some people outside the pitch and you will like misclassify them as a players. We actually
yeah,
have like many tricks like to just discard this classification, but like it's better for the model to understand that okay, these are the players, these are not.
yeah, yeah. I recognize that. How does auto production work?
Yeah, so the auto production, like we call the auto production, is like the process of like we have this camera that actually have like has the static like stream, right, without any rotation. And the auto production for us is just like we try to mimic movement of the operator of the camera and like crop some like box from this panoramic view and like you watch it as a viewer, like you might think that it's an operator. So basically, for the good auto production, it's funny, but you just need a good player detection and a good ball detection. Because like if you will look at the professional football stream, 95% of the time, what they're doing is just they following the ball. Sometimes
Mm,
they're doing a little ahead, like if the attack is from the left to the right, they're like having a little bit more space on the right, so because the ball will fly there and you won't be able to catch it if it flies really fast. So we're doing the same actually. We have like the detection of the ball each frame, we have detection of the players, so we understand like where the majority of the players are like standing, and if for example we have a player far ahead, like we need to zoom out to like see the whole picture and like for the viewer to understand that there will be like maybe some path there. So it's
mm.
funny how like when I first like watched it, like before I joined the company, it was interesting how this complicated at first sight process of operator moving the camera actually simple in terms of if you have the bounded the coordinates of the ball on the like panoramic coordinates of all players, you can guess the algorithm how like to move the camera.
Wow, interesting. How does it track the players then? And how are you able to calculate distances? You talked about it moving players moving from one side of the pitch to the other. And what I also think about is if in the Premier League, you're able to do player cams and you're watching players when they're not on the ball. So, you know, there's so many different things going on and you're analyzing those players that are not on the ball. So many thoughts are coming to my head. Let's start with the first question. How do you use auto production to track the game and calculate distances?
So the first thing is you need to understand that we don't need to track players and calculate the distances online. So the auto production, it just like follows the game, follow the action, follow the ball. So it doesn't give you any statistics of like distance covered
Mm,
or number of passes. Everything like this is going in the offline, the background, on the recorded session. So in this means you don't need to like put this logic inside a small box with like not very like not top of the shelf hardware, top tier hardware. I mean,
mhm.
so then when you have this recording, you can use like all the state of the art tool to detect, to track. For detection, for example, you can use like YOLO V5 is obvious choice. We use like a little bit modified version of that. For tracking,
YOLO V5. Did
yeah,
I hear that
YOLO
right?
V5 is like the best. I think it's like GPT-4 and GPT 3.5. Like GPT-4, it's very like it's much better and like, but it like cost more, have some timing issues. You can't like API GPT-4 if you don't have the beta version. So the same goes for YOLO v5 and, for example, YOLO v8. So if YOLO v8 is better, but like it has some problems with license, you can't use it in commercial use without paying Ultralytics, for example. There's some cash, which is actually big numbers. And like most of the people, they just use YOLO v5 for detection, and it's like pretty good. For the tracking, for example, the common networks people use is Deep Sort or Sort. It's SORT, just like that. But like recently, it's not state of the art. It's just like the most convenient tool to use. Recently, many computer vision engineers switched to ByteTrack. So ByteTrack is like also tracking algorithm that become very popular. I think it was published in 2022. So now like it's more or less common tool to use. And yeah, so after you have the detections, after you have the tracking on top of the detections, you can like play with different stuff. You can, for example, like recognize what is the number on the jersey of the player, right? Or you can estimate the, am I lagging? It seems like I'm lagging. Okay, sorry. You can estimate the pulse of the player. So like pulse of the player sometimes helps for the tracking, sometimes it helps to recognize specific movements, like shot on goal or something like that.
Hand up, hand of God.
Yeah. But like it becomes trickier when you working on like low resolution images. For example, we don't have any problems, for example, in volleyball in like pulse estimation, but in football it's a great problem, and like we need to find a solution how like within like several pixels you do the pulse estimation, because like most of the data set they like have a good image of the person, and like you have data set of these persons, and like all normal from here. Like there is no big issue of estimating the pulse of that. If you have like 10 or 20 pixels of the player, it's like hard to estimate its pulse. Yeah.
Interesting. Yeah, very interesting. I wonder, you mentioned about pixelation there and how some areas are easy to track and some are more challenging. I wonder what the accuracy is like. And I'm curious from a sports fan perspective, but I'm also curious because if you look into any industry field that's impacted by machine learning engineering, all the time, accuracy is a major priority for businesses. So, I wonder what the level of accuracy is for computer vision systems related to live sports streaming.
Yeah, I think it depends heavily on the quality of the stream, because, for example, like I think majority of our cameras are built for like third, fourth, five level tier leagues, so they cannot afford like multiple cameras, like really big bandwidth, like usually you do on like you expect on the like top tier leagues broadcast.
Like what I mentioned with the Premier League and doing individual player cams, that's not going to be possible in the lower leagues. I recognize that.
Yeah, so within this like field where we are playing mostly, you got a good understanding what's happening on the front side. On the back side, it's challenging to understand. In football, for example, in ice hockey, it's like quite better because like all the field is smaller, and same for basketball, same for volleyball. In football, like you have a really big field. Yeah. So depending like tracking, like if you have a decent jersey recognition, like we plan, like we don't have like player player-wise statistics right now. So it's our goal, I think, for this year to make the player-wise statistics. And like when you can like take the player number 45 and like you can like have clips where this player scored a goal or like made a pass or like did something. So right now it's really challenging because like when player is on the background, like you can't like really understand, like if two players cross each other, they have the same jersey, but the number is a little bit different. So it's really hard to track them out. So this is something that we are working right now. We can do it on like 4K videos, for example. We have like in our camera, we have like two switches. Like, do you want to have auto production along with recording? If so, like the auto production will be in a good quality, the recording would be not in very good quality. If you are going just to record the game and like have the statistics on top, yeah, you will have like very good recording. Then you see like everything and like it's I don't want to like give you a number because it's variable from game to game, from setup to setup, but most of the time you don't have any players which we even did a experiment when we did the like pulse estimation of all the players on the field. We put it in the 3D and we have like this 3D field of players you can like watch in different angles. It won't be the broadcast, but it would be like 3D people playing the ball, but it would be like the same as the actual game. So we can like play with some After Effects with this like matrix effects, if you understand what I'm talking about.
Yes. And that also makes me think about, you mentioned earlier about how you use computer vision to monitor and track games, and you also mentioned how analytics comes offline afterwards. So I wonder, away from the sports and more towards the professional for a moment, how does your work in computer vision engineering, how does it interact or collide with analytics professionals that you work with? Is it simply you hand over large files with algorithms built in? Are they doing much of the work? What does the interaction look like?
Usually, like let's talk not about football, but new game came in, right? Like I don't know, you can name it. Like for example, when we had ice hockey, for example, first time.
Hockey.
We got in touch with the professional coaches. We thought like, what do you want? Like what the market wants actually? What is the basic things that people like to have at the output when they upload the video or when they want to analyze the game? So usually for each game, there is some already standard thing that you want to get. For example, usually you need to get a score. Usually you need to know the timestamps of all the goals. Or for example, in ice hockey, you need to cut the clip in parts where you have even player numbers, or there is some disbalance, because in ice hockey sometimes it's 4 against 5, 3 against 5, something like that. So you want to analyze, you will be analyzing it yourself by the video, but for example, you need all the parts in the game when it was disbalanced in favor of your team. Did they handle it good or otherwise? And also there are some moments in the game that you need from the game, for example, face-offs. In ice hockey, there are situations that they have standing together, two players, and the referee drops the puck and then something begins. So all the face-offs needed to be taken out in several folder, and you will watch it alongside. Also, you want all the shots on goal, for example, or you want all the all the time the player number 7 was playing, for example, because in ice hockey they have switches all the time, so you need to track one player And for example, you need to analyze how this player is performing. So you don't need to watch whole game. You just need like to watch 10 minutes when he was on the game. And all these analytics, they like usually stand upon the simple task like detection, tracking, classifying the player, like understanding what is the jersey number, sometimes what is the pulse of the player, because like shots on goal like usually like is used with a stick and with rapid movements. And also like it's very important to have the decent quality of the like ball or puck detection, because like puck detection or ball detection identifies different situation. Like shots on goal is like very rapid ball movements towards the gate, or like passes is like if you know the position of the puck in each player in each frame, and you can like identify like which team had the puck, you can calculate time with the puck, for example, or like passes between one team. So they all are on top of this, and usually we like ask the professionals to manually annotate the game, like what statistics do you want, where are these statistics in the game, and then we like try our best to make this automatic, right? Like for example, face-offs. We say like, please tell me where in this like 2 hours games. There are no 2 hours games, but like 2 hours, there are face-offs in the ice hockey. And then we have like positions of the players, team classes, referee identification, and we're trying to understand like what should we do like to detect these exact times.
So you're gathering the requirements and you're coming up with solutions to those requirements. But did I hear you correctly say that you're asking the professionals what information do you need from these games to be able to analyze and make your own predictions, and then you come up with the solutions?
Really
how are you going to
stuff,
calculate
like
that?
really interesting insights. For example, if you have a goal in ice hockey, that means that the referee will whistle and it will show the hand. Like so within like, for example, if you have a microphone, you can like easily detect all the goals, or like you can detect all the situations that might be goals. And like if you have the pulse estimation, you don't need to detect the puck and the like gate, because sometimes it's not very visible, like is the puck came to the gate or not. So but you can like detect the referee within his pulse, and after the goal, all the players collect in the middle, and they have this face-offs in the middle of the pitch. So that's how we, for example, take the goals. In football, is like different story, but like it's usually there is some event that happens after this event that you're looking for.
And for example,
yeah,
sorry.
Go on.
I was going to say, if it's penalty, you'll know that the referee is typically stood at the edge of the box. They might put the hand up, they might whistle, everything is still, and then only one player moves, and then the goalkeeper responds.
Yeah, something like that. So you have some hypothesis, some rules, and you try to apply those rules. And if you have some data set on like there was these occasions in these times, so you can test it upon this data set and like see how many false positives and false negatives do you got from this game, or like from the set of the games.
Yeah. So it's easy for people. Have you seen the movie Moneyball?
I think it was about the analyst who made the best players, taking the best players from the old like. Can you please refer me, because I didn't see it.
Sure.
Like, I heard a lot of it.
Yeah, it's a great movie, and maybe from an analyst's perspective, it's just a good movie, but it allows people to see the work that goes into analysis of sports games. And as I understand, it's player analysis. So they identify the players' stats, how long they're on a field for the amount of time they're on a field, how many points they're able to accrue. and how they struck the ball, how they responded to certain pitches, based on segmentation and image detection, which the movie doesn't go into, but now I understand what is going on for them to be able to generate those data points. And then they use all this information, and they put a team together that's not necessarily a team of excellent individuals, but together they'll be able to produce the result you need to beat a certain team or to win the league. And they did that with the Boston Red Sox, and that was the first account of how analytics was deeply used in sports. Don't quote me on that, but that's my understanding.
What I know from this, like, it's the opposite side of my job, right? So like I usually do not connect like much with scouts. Like I think you're talking about like the scouts, people who are looking for the best players to put in the team. So as I understand now, if you're a scout and if you're in the like lower tier, like you're looking for the player for the lower tier league, you actually need to go and see the games, because there are no recordings of those games. There are no, like, if there are, like, in very rare cases, if there are recordings of these games, it's very hard, like, to find the right one, like where the player was played in, like, was it like on this position or on that position. So this is what we're trying to build in the SportTotal. We're trying to collect, like, for the season, all the games. And like, for example, if you're a team, you can subscribe and you will have like all the games within the season. And within this season, you will have like all the statistics on like each of the players. So it will drastically like make the scouts work easier, because now you don't need to get to the field, like you don't need to watch it yourself. You just like type, I need like player Joseph to like how he played in the previous season, and you will have all the clips with like maybe like highlights, maybe just all the clips where he played.
So it's an example of automating some of the job of a scout who would often be using intuition, that, and that's very typical in business, isn't it? Using intuition rather than data to make decisions.
At least he will have the input, right? How else can he make a decision, like without looking on like different players on the video?
True, but I mean, practically, how is a scout to get to 5 different games that all kick off at 3 p.m. in the afternoon on a single day? It's not possible, right? Okay, for the computer vision engineers, you earlier mentioned a few tools that might be useful: YOLO V5, Sort, Byte Track. Are there any other? Sorry.
So these are the networks. If you mention tools like some software, like we usually use like for the labeling, for example, the best tools I think on the market are like, there is a Label Studio which I used a lot before. In this company I use CVAT, stands for Computer Vision Annotation Tool. And you can, like, both of the tools you can automate, which is very good. Like when you finish something, like the next step will be starting. Or like you can put pre-annotation. For example, like recently we simplified the job of our annotators, like significantly, I think 10 times faster. Now they annotate stuff because like we implemented the pre-annotation to, like, for example, given already existent model, please drew all the bounding boxes, and now annotator just like refined them, or he just like find the ball because it's not like easily found and the model can't handle it. So CVAT, Label Studio for annotation, for visualization of the like results of the network or annotation results, we usually we use 51, which is like great thing to visualize the output of the model. What else? Yeah, usual stuff like Docker, like Docker Compose, like continuous integration in the GitHub. Like it's like the must-have, the essentials for any engineer, I would say, or maybe even DevOps or like ML Ops, if you're like broader thinking about this.
This is really helpful for computer vision engineers who might want to get into this. And I wonder if you have any recommendations for ML engineers who are interested in this field of work, as well as these tools for them to start playing around with. What other activities might they involve themselves in, either personal projects or professional ones?
There are many ways, right? Like, for example, there is Kaggle.com, like the common place where you can solve different competitions, and there are competitions according to sports. So you can like, actually, it could be diverse. You can like do computer vision, you can do analytics on top of already existing statistics if you're into sports. So Kaggle is a good place to start to like look around to understand how different people solve the same task. Also, like it's very interesting how our field like of computer vision evolves, because like things are changing pretty fast. There is like some basic tools that like will change maybe in 2 years, like YOLO will be used in 2 years, I expect. Maybe it would be like YOLO version 15, but like the basic idea and the basic framework would be the same. So I would recommend to like first to have a good basis, like because the basic, the mathematical basis, like the basic course of like convolutional networks, transformers will be still actual in several years. But the tools like will change drastically all over the years.
Yeah.
So don't be attached to specific tools. Like see what is used around, and for this, I would recommend to like be inside some community of the data scientists. Like in Berlin, we have like a lot of communities, and like people talk what different people like use, what is like commonly used, what is not so commonly used, and like talking to people is the best what you can do. Also, I don't know like how to improve this. Sorry, I went numbers.
No, it's cool. And I noticed perhaps there is a little bit of a lag on that last part about communities. Are there any communities that you're a contributor to?
Yeah, so like since like I came from like Russian speaking communities, even in Berlin we have like our small bubble. Huge
I'd
bubble.
say a bigger bubble. Yeah.
Yeah, so usually I like talk within these conferences and communities. Basically, like it's hard to make a suggestion what is the best. Like subscribing to Twitter accounts of like people in the field may be a good choice, or Reddit accounts. Now, since like a lot of stakes been put it into stable diffusion and all these tasks, I think it's worth to get to touch with it, because like who knows, tomorrow we'll be doing like already we are doing synthetic data sets, and like it's a good plus. So getting to know new technologies, it's at least it will get you some topic to speak about when you meet some person from the field, right? And it's
Brilliant.
like it become very easy to get in touch with. Like you can just open YouTube, type like how do I generate a image using stable diffusion. You got like dozens of manuals.
Okay, thanks. That's super. I've taken note as well. My final question, the future. How do you think the use of computer vision in sports games will evolve?
I expect a big influence of sensor data. So right now, like there are some projects involving like putting some sensors on the legs, in the ball, like everywhere. So you will have not only the like visual data, but also the like IMU, inertial measurement unit data from the field. You will have like multiple cameras, because like cameras are not very expensive. And like, for example, if you just, and the bandwidth of the internet become like better, so you can like have 5G internet, and like you can translate a big amount of data. So right now we are recording, and I don't know, like gigabytes, like many gigabytes, maybe 100 gigabytes, and we can transmit it through the internet. We didn't need like LAN connection for that.
Yeah.
So the number of cameras will improve, and you will need to like stitch all these cameras, like better understand the pulse of the player from different cameras, and that will give you the perfect transition from this playing side view, when you have like some pixels playing on the on the picture. You will have volumetric data. And maybe you will have like volumetric cameras even, because like if you put two cameras together, you will have like binocular vision, and you will can estimate the distance. So all the games would be translated to the 3D field, and you can do like multiple things with this. Like first, like what comes in mind is like 3D effects of the like production of the broadcast, and like this will become better and better. But now you can like estimate the speed of the ball. You can estimate the pieces, the hardness of the kick, everything you want to do, like it could be done. And hiring the frames per second, because like usually like the normal camera will produce like 25-30 FPS. It can go like far beyond that, and you can like watch the same movement in very like how it's called, like slow motion, right? Everything you want could be slow motion, so you will have like better highlights, better maybe better immersive experience of watching the game, right? So it's hard to predict, but like the hardware is getting better, the bandwidth is getting better, the networks are getting better. So I expect the experience from the viewing of the sport will be better, and the analytics on top of that would be better.
Insightful, incredible. So we're seeing an evolution, as we are all the time with tech, but the influence of sensor data, the first point you've made, could be something that significantly changes the game of analytics for sports.
Yeah, it would be nice to have the bit rate of Ronaldo when he scores the ball, right, on the field.
Yeah, I'm not really interested in Ronaldo.
I'm not sure. Like,
yeah, I'm joking. I'm only playing. We won't get political. Igor, thanks so much for today. I really appreciate you coming on. For those nobody will know, but we've done this last minute, so I really appreciate you giving me your time today and your kind of off the cuff technical expertise on this unique field of machine learning. So thank you very much, and I'll look forward to talking more in the near future when I come up with another topic to quiz you on.
All good. Thank you for having me again.